Finally, we have Sreejith IV, an SW intern at ICFOSS. Sreejith will be presenting on assembling an infrastructure sharing platform for e-learning. He will introduce an online platform for creating consistent and scalable virtual machine infrastructures for educational environments. Let's welcome Sreejith to the stage.
So, good afternoon, everyone. Hope you guys enjoyed the day at DevOps Days Kerala today. And this is actually the last talk, so I won't drag it a lot. This will be quick. And so 15 minutes on the clock. Let's get started. So this talk is actually about a project that we did at ICFOSS to solve a particular problem. So first, a little bit about me. I'm an intern at ICFOSS. So being an intern over there means I get to do all kind of cool stuff with free and open source software. From writing code to managing servers and everything in between, I get to do all of that. And of course, contribute back to the community. So about the project, let's first understand what problem that we were trying to solve. So we at ICFOSS not only do projects on various domains like e-governance, IoT, open hardware, cybersecurity, etc. We also do courses and training sessions on these. And we do this both online and offline. And most, if not all of these online courses have a common problem. And that is the platform. Platform is problematic. And what do I mean by that? So all of these users or students that get enrolled into these courses will have various platforms, and they are fragmented in terms of the machines that they're using. So most of them will be on Windows, some of them will be on Linux, and some of them will be on Mac OS. And some of them will be rocking one underpowered laptop that can't even play a 4K video, let alone train a machine learning model. And it's a nightmare for the trainers too, because now they have to help individual users set up their machines just for the course. And we are talking 50 to 100 people. So we wanted to fix that. We wanted every single user to attend those courses, and so that's what we were trying to solve. So ideally, our solution need to be purely browser-based, meaning installing any kind of software on the user's computer out of the equation. And it has to be fully automated. That means our system admins have to do as much little work as possible. And finally, our platform need to have access to all of the software that the students need to attend these courses. And that's exactly what we did. So for this system to work, we need a couple of components, and we'll look at them. The first one is Proxmox. Now, Proxmox is a free and open source hypervisor, and since we will be creating virtual machines essentially, we need a hypervisor. And Proxmox has this interesting feature where it allows us to share or expose the virtual machine's display, the video feed, out of its web UI. And we will take advantage of that. And the second one is LDAP. Now, LDAP stands for Lightweight Directory Access Protocol. It has a couple of implementations. One famous one is Microsoft Active Directory. And we use OpenLDAP, which is free and open source version. And LDAP basically allows us to store organizational data and user credentials in a hierarchical manner, just like that. And the third one is Apache Guacamole. Now, without Guacamole, we wouldn't be able to satisfy our first condition. Because what Guacamole allows us to do is, it basically takes those video output that we talked about from Proxmox, and it allows us to put that on the web browser. So that's what Guacamole does. And the final one is LTSP. Now, LTSP stands for Linux Terminal Server Project. And it is an amazing piece of software and a great author behind it. It basically allows us to boot these machines, be it physical or virtual, over the network instead of traditional hard drives or SSDs. And with LTSP, it means two things for us. First one is that we no longer have to allocate disk space for our virtual machines. Our VMs can now be completely diskless. And it basically brings down our VM creation times to under 5 seconds. And the second one is that we now only have to maintain a single LTSP, a template image that is also called an LTSP image. We basically pack all of the software that we need for the course into this image and export it as an LTSP image so that those VMs can boot off of it through the network. So now we've seen the components. Now let's see how it is assembled together. So we have our user and our Apache Guacamole front end. And user logs in, he will be seeing a login screen where he will enter his username and password, which will be given to him before the course. And when he enters it, it basically takes it to the Guacamole backend, the Guacamole server. And from there, it will authenticate it with an LDAP server. Now, once this authentication is complete, the user is successfully logged in, our Guacamole server does one more thing. It basically checks if the user has any VMs associated with it, with that user. And if there is, it basically pulls some details from the LDAP server. And those details are the server and port address of our Proxmox server, where it should connect to get the video output of the VM. And once it has that address, it's basically connect to our server and sends a wake on LAN packet. Now, wake on LAN packets are this basically a magic packet that is sent as a broadcast on the network and basically starts up machines. But we have a problem here. We don't have physical network interfaces cards. These are all VMs, and the network interface cards are also virtual. And once the VM is powered off, we don't have anything to capture those packets. So what do we do here? We have a custom script running on a hypervisor for listening for these packets, and when it gets one, it basically split it apart, get the MAC address, and start the corresponding VM. And our VM is started. So we are not done yet. When we start our VM, it will first try to boot off of the disk, and it will fail because we haven't given it any disks. So the next best thing it can do is to check for PXE booting mechanism. That is what LTSP uses in the first place. So our VM looks for these LTSP images on the network, and our LTSP server, which is on the same network, basically serves these LTSP images. And our VM starts booting and basically reaches out the login screen. And once it is on the login screen, the user is able to actually use the same username and password on this VM because we configured the LTSP image to also authenticate against this LDAP server. And once that happened, there is a pluggable authentication module, also called PAM module, with LTSP, which basically authenticate this user with the LDAP server. And that's the architecture. And now I will show a quick demo. It will take a little. So the user is logging in. And that's the PXE screen. Got an IP address. As you can see, we have a couple of images there. The Kali Linux image was for our cybersecurity course, Pi was for our Raspberry Pi course, and QGIS for our geospatial information technology course, and Ubuntu was for a generic Linux course. And the user can select one of them. And as you can see, we have the kernel and initrd loading through the network, that is. And once on the login screen, he can enter the same username and password since both of them are configured with LDAP. And from there, the user has full access to our infrastructure and compute, and we have some GPUs and workstations set up on that network for their use. So that's the system that we've set up, and if you guys want to replicate or do anything similar, I have a tutorial like documentation set up on that URL, and that's a corresponding QR code. You can scan it, and if you guys have any questions, I'm available on LinkedIn. So if you guys have any questions now, you can shoot. Thank you.
Thank you, Sreejith, for the enlightening session. Let's welcome Ranjit Rajaram, our core team member, to hand over a token of gratitude.